I will affirm the resolution. This House believes there is no such thing as an unbiased dataset. Opening statement. The concept of a perfectly unbiased dataset is a myth, an ideal that is unattainable in practice. Every dataset, no matter how carefully constructed, inevitably carries biases that reflect the circumstances of its creation, collection, and the inherent limitations of the real world it attempts to represent. These biases can be subtle or overt, intentional or unintentional, but they are always present. To claim otherwise is to misunderstand the fundamental nature of data, and its relationship to the complex world it describes. Arguments. Selection bias. The very act of choosing what data to collect introduces bias. No dataset can capture everything. Decisions about what to include and what to exclude are inherently value-laden, reflecting the priorities, perspectives, and limitations of the data collectors. For example, a dataset of historical figures will be biased by who was considered important enough to be recorded at the time, which often reflects societal power structures. A dataset of images will be biased by what images were available and chosen to be included. Sampling bias. Even if the selection criteria are seemingly neutral, the sample of data collected is almost always biased. It's rarely possible to obtain a truly random sample of the entire population of interest. Convenience sampling, self-selection, and underrepresentation of certain groups are common problems. For example, a survey conducted online will inherently exclude those without internet access, introducing a bias towards more affluent and technologically literate populations. Measurement bias. The way data is measured or recorded can introduce bias. Measurement tools can be inaccurate or calibrated differently. Human observers can have different interpretations or apply criteria inconsistently. Even seemingly objective measurements can be influenced by subtle factors. For example, the wording of survey questions can significantly influence responses, leading to biased results. The race or gender of an interviewer can also influence how a participant responds. Historical bias. Data collected from the past reflects the biases and prejudices of that time. Historical records are often incomplete, inaccurate, and reflect the perspectives of those in power. Using historical data, without acknowledging and accounting for these biases perpetuates them. For instance, crime statistics may reflect discriminatory policing practices rather than actual crime rates. Representation bias. The way data is represented can introduce bias. This is particularly relevant in machine learning. If a dataset used to train a facial recognition system contains mostly images of white faces, it will likely perform poorly on people of color. This is a representation bias, stemming from an unbalanced dataset. Similarly, text datasets can reflect the biases present in the language used, perpetuating stereotypes and prejudices. Observer bias, confirmation bias. Data collectors, or analysts, might unconsciously, or consciously, look for data that confirms their pre-existing beliefs, and ignore data that contradicts them. This confirmation bias can lead to biased data collection, analysis, and interpretation. Algorithmic bias. Even if a dataset was somehow perfect, the algorithms used to analyze it can introduce bias. Algorithms are designed by humans and reflect human choices and assumptions. These choices, even if seemingly neutral, can have significant consequences, leading to biased outcomes. For example, a predictive policing algorithm trained on biased historical data may perpetuate and amplify existing inequalities. The impossibility of complete neutrality, the very concept of unbiased, is problematic. Every observation, every measurement, every act of data collection is filtered through a lens of perspective and interpretation. True objectivity is an illusion. We can strive for fairness and representativeness, but we cannot eliminate bias entirely. Rebuttals to anticipated opposing arguments. Random sampling eliminates bias. Random sampling reduces bias, but it doesn't eliminate it. True random sampling is often impossible to achieve, and even the best efforts can still result in a biased sample due to practical limitations and unforeseen factors. Careful data cleaning can remove bias. Data cleaning can address some biases, particularly those related to errors and inconsistencies. However, it cannot address deeper, more systemic biases related to selection, representation, and historical context. Objective measurements are unbiased. Even seemingly objective measurements can be influenced by subtle factors and biases in the measurement process or in the underlying assumptions. What constitutes an objective measurement is itself often a subjective decision. Synthetic data can be unbiased. Even synthetic data is generated based on rules and parameters set by humans, and these choices can reflect existing biases or even introduce new ones. The model used to generate the synthetic data is trained on real-world data, inheriting its biases. Closing statement: the pursuit of unbiased data is a worthy goal, but it's crucial to recognize that it's an ideal, not an achievable reality. Every dataset is a product of human choices and the complexities of the world, and therefore inevitably carries biases. Acknowledging this inherent bias is not a weakness, it's a strength. It allows us to be more critical of data, to understand its limitations, and to develop methods for mitigating the negative impacts of bias. Transparency, careful documentation, and a constant awareness of potential biases are essential for responsible data collection, analysis, and use. We must strive for fairness and representativeness, recognizing that perfect objectivity is a myth.